this is the last presentation for this session before the break. It's my pleasure to join Hooncheol. I hope that I pronounced your name correctly. Which I believe you came from Korea, right?
Right.
Yes, with people from Makina Rocks. So he'll be talking about ways to collaborate, which is very important on our age and science. So thank you, Hoshim, and have a great presentation.
Yeah, thank you. Hi, everyone. What a big stage. I guess that is first presentation. Hello, bonjour. This is Hooncheol, and I'm here to talk about the easiest way to collaborate on Jupyter. I prepared the presentation with my coworker, Hooncheol Shin. And to briefly introduce myself, I work at Makina Rocks, where we develop ML products called Runway and Link. The model development process here. The model development process, which involves pre-processing data sets and creating pipelines to build models, is a critical step from an ML perspective. We've been thinking about how we can collaborate better in this area, and this presentation is the result of that contemplation. So I'd like to start with the outline of today's presentation. Firstly, I discussed two problems related to Jupyter: reproducibility and Git integration. I briefly mentioned Makina Rocks link, and then present ways to share pipelines and caches to help reproducibility. And I'll also talk about how to use Git in Jupyter. Finally, I summarize my points before ending my presentation. A collaboration is very crucial in the workplace, and it occurs daily. Collaboration enables us to produce better results. And as teams grow, effective collaboration becomes increasingly important. Machine learning engineers also collaborate extensively on their code and results. They can read and understand each other's code, reproduce it, improving their own code in the process. As you all know, Jupyter is a very familiar, widely used tool for data scientists. Jupyter provides an outstanding interactive feature that allows the REPL-based execution and review of cell-level code results and facilitates data exploration and machine learning experiments. Jupyter allows for fast iterations, leading to more trial and errors for you to achieve your end goals more quickly. However, the high level of flexibility of Jupyter leads to very different user behavior for each and every user. So we would like to propose a way to collaborate seamlessly on Jupyter. Now, I have a question for you. You guys can answer at any time. Have you ever collaborated on Jupyter? Yeah, I'd like to quote a post by Damian Benveniste, who suggests using Jupyter only for prototyping in machine learning projects. He says that the order of code execution in cells can be confusing, and that Jupyter doesn't provide the robust framework for improving code reusability and manageability. Furthermore, people tend to copy and paste code snippets from one place to another. Yeah, we know it. So, like Damian mentioned, people seem to utilize JupyterLab primarily for prototyping purposes. As a result, they often do not neatly organize notebook files to share with others. Moreover, when receiving a notebook file, it might not be reproducible in your own environment. Due to the JSON format of Jupyter files and the usage patterns of Jupyter users, version control of files isn't easy. For these reasons, I haven't seen many cases where people collaborate using Jupyter. So, all right, now we are gonna discuss the problems we want to address. But let me ask you a question first. again. Anyone can answer right away. And hands up. Have you ever failed to reproduce someone else's notebook? Yeah, I saw many. Let me share an example with you. Two people are talking. Someone says, "I've sent the notebook file." The response goes, "Thanks, but I got no module error." Oh, please, yeah, another guy said, "Oh, thanks, but I got no module error." "Oh, please insert the NumPy package." Cell number 3 first. Run it in the order of number 7, 5, 3, 4, 6. Oh yeah, it's working. But number 8 also fails. Run number 9 before 8. Accuracy is at 30%. What? I got 95%. Some of you might be familiar with this kind of situation, right? I think it's quite possible. In this example, it seems that the development environment wasn't properly delivered. Also, the notebook sequence wasn't well organized. So the person who received the file couldn't reproduce it properly. Anyway, to solve these issues, if we need to more than just sharing notebook files. If we can share notebook files in reproducible forms and the results of notebooks with others, it should be possible to reproduce them. We'll talk more about this later. I'd like to touch on another issue. Let me ask a question again. Have you ever collaborated with Git on Jupyter? Oh, some people. Wasn't it good? Have you ever managed a file like this? I remember managing a file like this, finer, real finer, real lost finer. I remember managing files like this when I was a student. In reality, if we use Git, we don't manage file names like this. However, I brought this image to show a clear example how difficult it is to use version control with notebook files. So for me, I can say that I always work with Git during my job, so I'm pretty familiar with Git. But when I think about using Git, I don't seem to use Git's features with notebook files. So this GIF is showing what I do after Git config on Jupyter. Yeah. From the first. Yeah, I pull, and it got conflicted. So I can't open the file on the Jupyter. So I just opened the notebook with a text editor like Beam. And so the angle brackets, so it just resolve conflicts like that. And it's unpleasant for data scientists. And this is a problem similar to how it's difficult to represent Git conflicts, as it is often difficult to express changes or differences in notebooks. One of the reasons for these issues is that the file is in JSON format, and moreover, the JSON format contains various information in a single cell, such as output or execution number or metadata. And we all know, right, when using Jupyter, we freely create and delete with shortcuts like B or DD or A, and copy and paste code here and there. So I think these factors make it challenging to handle notebook differences caused by commits. So we believe these problems can be solved if we can properly assign identities to cells. Let's take a look at how we've solved this issue later. So I'm so fast. Before introducing the solutions for today's problems, Let me introduce Machina Rocks link. This is a pipeline building tool that we provide as a Jupyter extension. It's available with pip command. And in Jupyter, each cell becomes a component, and by connecting them, the tool provides a pipeline feature in the form of directed or cyclic graphs. Take a look at this GIF. We can make a pipeline with plus button and put the name and just put the parent's information, and we can make a pipeline there. It's too easy. Specifying a component means assigning an identity to that cell. Thanks to this, we can do a lot more. For example, we can cache the execution results of specific components. We can separately store the results of running this component and that component. And when there's a conflict in Git, we can compare my changes and someone else's based on the component, including, introducing such a pipeline can improve reproducibility itself. This is because it specifies the order in which the cells must be executed, and they run accordingly. In the image, there's a link Git tab. Can you see there? In the another here. It's inspired by Jupyter-git. This tab allows you to perform all basic Git operations, and it also provides features to solve the two issues I raised earlier. By offering this pipeline feature in Jupyter, we want to propose standardization for machine learning projects. In addition to this, we provide various other features such as remote execution or hyperparameter optimization and parallel execution. However, today we will focus on pipelining and link it. Now, let's solve the notable reproducibility issue. It's about sharing pipeline and cache. As you just saw in the slide, you can easily create pipelines in Jupyter using link. Additionally, we mentioned that we can cache the results of each component. So the way to export is super easy. You can see the GIF. After this, I just wrote the pipeline and I'm exporting as a files and cache exporting, and then I open a new notebook, and then I can import the pipeline from the file, JSON file, and I can import the cache again. So is reproduction all done? We can get the old result. We can get the old result. And beyond reproduction, sharing a pipeline skeleton can also help improve teamwork. We've used this approach internally, and it's been reported to be easier to adapt to, as it makes understanding the overall structure more accessible. The pipeline we create can also be exported as Kubeflow pipeline with right-click again. From an MLOps perspective, data scientists and MLOps engineers can communicate more easily and collaborate through these pipelines. In our product, Runway, once a pipeline is created in link, clicking a specific button automatically registers the pipeline to Runway, making it useful for tasks such as retraining. There was a poster session to introduce these functions to a machine learning project last night. It says that the projects used to used to take 4 weeks was reduced to 1 week. Now let's talk about how you can use Git in Jupyter through link Git. Because we've introduced pipelines, each component has an identity, which means if I use this component as loading data set, it should be for loading data set. But if it's not a component, only just cell, we can delete it easily and just we can copy paste another section or something like that. But if we name that as loading data, so we will use it for only loading data. So because we've introduced pipelines, each component has an identity, making it easier to show diffs based on that. On the right side is a screen in link Git showing the diff between pipelines as a result of a commit. So you can see this image. Before is this one, and then is edited, removed. We can see easily. By showing the pipeline diff based on commits, it's easier to understand the changes in the pipeline. Now, finally, let me introduce a way to resolve Git conflicts through link Git. We believe that the most desirable way to resolve conflict is to use the editors we've already working with. In this case, definitely Jupyter. Link Git helps you resolve conflicts in the Jupyter editor when Git conflicts occur. First, let's understand the background situation. Base is an initial state, and I and another team member will start working on this pipeline. I call them X. I change this source code, and current is for me. I change it component 1 source code to A equal 3, and X changed it A equal 2. And C component 3.1, I changed it name to component 3.1.2 and source code to D equal 1. And X changed it 3.1.1 and source code to D5. Yeah. So do you understand? Now what happens when I pull the above branch? We introduced a custom merge driver for automatically for helping us to open the notebook on Jupyter. So if only the source code changed, it reference conflict within cells with angle bracket as usual, like this in a cell, and if other metadata such as component names or parents information have also been modified, it guides conflict resolution by creating separate components for each. Where's my point? Here. So you can remove what you think you don't need. Take a look at this GIF to get a better understanding. You can think of as a situation where I'm just pulling. I pulled, and automatically, so I can open the notebook on the Jupyter. So I can resolve conflicts on there. Yeah, I pull and go into the editor to resolve the conflict directly. Yeah, that's all. Let's conclude. Our goal was to contribute to a more collaborative environment on the Jupyter platform, making it easier to work with others, work with others. MLOps, in other words, enabling machine learning to have a real-world impact, is what is what we will continue to analyze and research. We are constantly thinking about how we can improve collaboration with the realm of MLOps, and give Link a try. Create your own pipelines and collaborate with them. Experience the various features it offers. You can install it with pip install mrx link command. Of course, it's free. To briefly introduce, Link is for developing model and pipeline tool using Jupyter, and Runway covers more operation things, such as model pipeline management, model deployment, monitoring, retraining, and you can move back and forth seamlessly. If you want to learn more our ML product, please feel free to contact us. You can find out more visiting our product page. So, yeah, that's all. Thank you.
Thank you. Do we have questions from the audience?
I don't know if the question will ask for an answer immediately or later. But the point is, we have been working on a pull request to enable a second format for Jupyter notebooks, which is text-based. And people in the community have been experimenting with text-based notebook for quite some time. And one of the motivation is version control. So my question is, please give us your feedback about this pull request to see if this would possibly help solve the version control problem in your kind of settings. So let me take it in short. So this version control problem is something that many of us have been facing. And there is currently a pull request to enable markdown-based notebooks rather than JSON-based notebooks, so that it's easier to do version control. We would love to have feedback. So my question is, please give feedback. Well, of course, not now. Thank you.
Thank you.
Any other questions? OK, so please help me with a round of applause for our speaker.